connected to the AI assistant.
Hey Samantha, how you doing?
I'm doing great. Thanks for asking. It's nice to chat with you. Is there something I can help you with?
Yes, awesome. Can you please tell me what is 39 times 42?
The result of 39 times 42 is 1,638.
Awesome. Can you multiply that by 4?
The result of 1,638 times 4 is 6,552.
And can you sum 2025 to that?
The result of 6,552 plus 2,025 is 8,577.
Awesome, Samantha, you're amazing.
Thank you so much. It was my pleasure to help you with the math calculations. If you have any more questions or need help with anything else, feel free to ask. Have a great day.
Hello everybody. In this video I'm going to show you the simplest way for you to have a real-time voice conversation with an AI agent on your phone, right? So this is just something that now is made super simple by one thing that is now called real-time voice frameworks. And I'm gonna first explain you what are these and which is the one that I'm currently using. And I'm going to explain you also the difference with the kind of like the OpenAI real-time API, which is also a real-time voice framework, but that would be closed source. And then I'm going to demo it to you. I'm going to use a conversation with a LLaMA model, so the LLaMA 4 model, the latest model from Meta, and just how everything just works with your phone, which is amazing. And this video as well serves as a continuation to the previous video that I uploaded, in which I show you how you can just have a full voice pipeline directly working on your local machine. So for that video, I only made it with 19 lines of code, which is crazy. And this is because I was using this new framework called FastRTC. So yeah, I want to explain you how I made it work in this video, because in the previous one I just didn't have time for that, and show you another example here that is just completely run by Groq Inference. So both for the speech-to-text, text generation, and also text-to-speech. So all that is run via Groq, so that way you can just run it yourself. So this wouldn't be running your local machine, of course, but it would be, so you would be able to just set up this application yourself and just use the free API from Groq and just have this running and just test it yourself. So let me first start by just showing you this diagram, which is something that I recycled from my very first video on this channel. So I don't know if you have seen that video. If you haven't, you should have a look at it, because I think it's quite cool. So in that first video, I was just telling you about how amazing are these speech-to-speech frameworks, right? So so I released that video back in September, October last year, when the real-time API from OpenAI, so this API was released, which was amazing, right? And this is something that I told you at that point, right? That just by having this simple speech-to-speech communication, so kind of like the distance between thought and action was just super short. The thing is, like, this no longer applies. So, and let me just remove this. I was saying that, yeah, in the past you would need to do like speech to text and text generation and then text to speech, and all these would be like too slow, and then the distance between thought and action was too fast, so too far away. The difference now is that now we have just these inference providers like Groq that are super quick, and we have better and more optimized models for every single piece of this pipeline. So now this is no longer slow. So now I'm gonna be showing you today how this all works now extremely fast, right? So, and now the difference doesn't come now from this distance from thought to action. Now it's more like open source versus closed source, right? So these are now the examples of closed source frameworks that I can give you, which is the OpenAI real-time API that I'm not using any longer because it's very expensive. So at that point I was using some Azure free credits, but now it's just like still like I think around €1 per minute, which is just too much. The Gemini Live API, this one I'm using for projects and things, because this is free for you to use for like many tokens per day. So this is actually quite nice, but it still is closed source, right? So you're having this speech-to-speech interface, and you cannot control many things of this pipeline. Right? You maybe can control the voice that this system is gonna answer you with, but nothing else, right? And now this is just the cool thing. Now over the past months, there's been this new FastRTC pipeline. So FastRTC that I have here, which is this real-time communication made by, I think, the people at Gradio, the people at Hugging Face, or at least I think so. And it makes it super, super easy to just build these real-time applications. And then there's also this other one that I think has been here for longer. It is much more complete, it's much more robust, but both more or less, they serve the same purpose, which is that you can build these voice pipelines, right? And now you can do whatever you want with all these steps, right? So you can just take whichever model you want and whichever inference provider for your speech to text. So right now I'm using Whisper from OpenAI via Groq Inference. I'm using LLaMA 4 via Groq, and I'm using also Play TTS via Groq. But the thing is that you can swap everything here. So that's why in the other video, that if you haven't seen, you have to see it, in which I built this whole pipeline running on my local MacBook machine. I was just using LLaMA as the inference provider, just running on my machine, and the Gemma 3 models. I was using Kokoro TTS model for the text-to-speech, and I was using a Moonshine model for speech-to-text, also running on my local machine, right? So this is the cool thing about this thing, is that you can just change anything that you want, and you can have it just running for free, and you can control the cost, you can control the inference time. So this is really, really cool about these frameworks. And something else that you should know about these frameworks is that you also have this video. So I think it's called VAD model, which is video or voice and so let me just Google that, VAD model, and that is voice activity detector, right? And this VAD model, what it does is just exactly that. So it detects when there is a pause in the speech, and it detects when there is a voice, right? And when there is a voice, then the whole pipeline, right? This pipeline will run once there is a pause. And now let me just show you the code, because I think you're going to see it like even more clearly. This is the project that I've prepared for this demo. I've also uploaded this to my GitHub profile, so you can just quickly just clone it yourself and just test it by yourself. And maybe, I think at the end of this video, I'm just going to demo it to you how you can just quickly just clone it and just set it up and run it. I put all these instructions here, but just in case, in 2 minutes, I can show you that. And yeah, the thing is, like, it's just super, super simple. It's not 19 lines of code, but maybe it's like 50 lines of code, and in just a couple of lines of code, you are going to be seeing this pipeline, right? So what we have is a response method that is the one that we use when we establish this stream object, right? So we are using, again, the FastRTC library. So we can see this, how we take it from here. So we use the FastRTC, and we use a couple of different abstractions or models. So the one stream is the most important one. So this is the one that controls just the stream, right? And we just said, okay, we want to have this audio modality. We want to be able to send and receive audios. And then we want the handler to be reply on pause. So that is, every time there is a pause, the method response would start, right? And then we just say, okay, I want the speech threshold to be like this. You can change all these algo options here easily. And then the method itself, the response method, is just doing exactly what we have here. So it's doing a speech to text, text generation, and text to speech. And you can just, as I said, you can control anything that you want here, but I'm using Groq everywhere. So that's why I'm using this Groq client. And then I'm using a method to create the transcription from the model. So, right, so we get an audio, right? So once there is a pause, we get the audio in this method. So we have to do the transcription. Then once we transcribe it, then we go and generate an answer, and we use an agent, because actually in this video, I'm using a proper agent, not like in the video before that was just like kind of like a chatbot. And here I'm going to show you later as well what is this agent. Once we have the answer from the agent, what we do is we do the generation of the speech. So here I'm using the local Kokoro model because the quality of the audio is really good. But in the repo that I've uploaded, you can just go and check it here. I'm using the TTS response, so this text-to-speech response that you can use via the Groq client. But yeah, the quality of it is just not as good, I think, in my opinion. And that's it, really. And then I just have the main here controller just to create the stream. And then I have two options. So in this video, I promise you that I'm going to show you how you can interact with this agent via your phone, right? With this whole voice pipeline via your phone. So I'm going to just demo that to you. But you can just also have it running on your browser with the Gradio user interface. And now, as for the agent itself, I just created this Python file, just super simple. I call it simple math agent because it's just the easiest way for you to create an agent in LangGraph. So I'm just using this create React agent function from this pre-built library, which is just, it just creates this reasoning and acting agent, or this agent with this framework, which is the simplest one. And it just makes it very, very easy for you to create an agent with LangGraph without just the need to just set up the state and so on. So this is just for the sake of this demo. I just wanted to make it simple. So you create a React agent, and for that React agent to work, you need a model, you need some tools, you need a system prompt, well, if you want to, but of course I said it, and you also want to have a memory, right? So I just made it like the simplest thing for you. Let us just have a look at it as well. So for the model, I'm just using the chat Groq abstraction from LangChain, which allows you to create a chat model using the Groq API. So here I'm using LLaMA 3 or LLaMA 4, so both they work really, really well. LLaMA 3.3 70 billion is a bit faster, so that's what I'm using it right now, but it's just the same. And also I have used the two simplest methods, so this is kind of like a math agent that I call. So it's an agent that is able to use sum numbers and multiply numbers, and we use this as tools, and then we just create these tools array, and then you send that to the constructor. And then as for the system prompt, we just say, okay, you're a helpful math assistant, and you should be using your tools to answer about these math operations, right? So we don't want the LLM to hallucinate when it gives you answers to math questions, right? We want the agent to use these tools that actually use Python calculations. And that's all, really. So I just made it like super simple for you to just get a hang of it and understand it. It just has these three different methods. There is another one as well to just process the answer from Groq, right? But this is just, as I put here, is just to process this response and just create an audio with that one. All right, now let me just demo this to you, just running first on the browser, on this Gradio UI interface that FastRTC just provide us with. So we can just call this FastRTC Groq voice stream script or Python script. So use Python FastRTC. Okay, it sets up everything. It opens, so it gives us this local URL. So we can just click there and now record, and we can just have a conversation with, I actually call her Samantha. Hey, Samantha, how you doing?
I'm doing great. Thanks for asking. It's nice to chat with you. Is there something I can help you with? Maybe a math problem you're stuck on?
Yeah, actually, can you tell me what is 39 times 42?
The answer to 39 times 42 is 1,638.
Awesome. Can you multiply that by 4?
The answer to 1,638 times 4 is 6,552.
And can you subtract that by 1,000?
The answer to 6,552 minus 1,000 is 5,552.
Thank you. You're amazing, Samantha. Bye-bye.
You're welcome. It was my pleasure to help. Have a great day and feel free to come back if you need anything else. Bye-bye.
Okay, perfect. So that worked really, really well. I think everything was just perfect, right? Like the transcriptions were perfectly fine. The inference time was super, super quick. We see how the agent is calling the tools that it has to call every single time, so it never hallucinate or just give an answer from kind of like the text generation. So it was always using this method. So perfect. So that was really good. And now, as I promised, I want to just demo this or the same kind of like interaction, but just having a phone call with the agent. And for that, I'm going to need to just change the cameras because I'm recording right now with my phone, and I'm going to need that to make the call. All right, now I just changed cameras. So now I'm recording with my webcam, and so that you can see how I'm having a conversation with the agent with my phone. So for that, we can just run the same method as before, right? Which was the FastRTC, but now we put the -- phone option. We click enter, and this is going to instantiate the same streamed object from before, the same pipeline, but the interface is going to be different. So now, instead of having this web interface, our interface is going to be our phone, and we can just call this number here and then put this code, and we are just having the conversation with the agent, which is crazy. Okay, so let me just get this call going. So that I'm going to call that number, which is just the number that is given to me or to my Hugging Face account, which is for free, 30 minutes per month. So I call that number.
Your code followed by the #.
So I have to insert that code here.
Connected to the AI assistant.
Hey, Samantha, how you doing?
I'm doing great. Thanks for asking. It's nice to chat with you. Is there something I can help you with? Maybe a math problem you're stuck on. I'm here to assist you with any calculations you need.
Yes, awesome. Can you please tell me what is 39 times 42?
The result of 39 times 42 is 1,638.
Awesome. Can you multiply that by 4?
The result of 1,638 times 4 is 6,552.
And can you sum 2,025 to that?
The result of 6,552 plus 2,025 is 8,577.
Awesome, Samantha, you're amazing.
Thank you so much. It was my pleasure to help you with the math calculations. If you have any more questions or need help with anything else, feel free to ask. Have a great day.
Thank you. Bye-bye.
But the call has been disconnected.
Okay, and that was it. As you can see, so the conversation is the same kind of a conversation that you can have via the web interface, but this is just via my phone, and everything is being processed in my machine. So this is amazing. So the kind of applications that you can build with this is amazing. And finally, to finish up, let me just quickly tell you in 30 seconds how you can just get this whole thing running by yourself. So you just need to clone this repo that I prepared for you. It's going to be the first link in the description below. So you can just get this link. So you can use HTTPS, just clone like this. You open your terminal. You just go and say, and you just need to git clone it, right? That's it. So you can just open it with your favorite IDE. In my case, it's just Cursor. So that way you can just go like this. So this opens the project in my IDE. Now, the only thing that I put here is that you have to open the terminal. You have to create a virtual environment. You have to sync it with UV so that it's going to install all the dependencies. And once this is done, you can also just set up like this. So you can just set your exactly. So now it's using this. Now it's using this virtual environment in this machine. And then the other thing that you have to do is you have to copy this guy, then rename it, put it as .env, and then you just need your Groq API key. And for that, I also prepared this link. So you just need to go to the Groq console, create an API key. You say FastRTC, right? Groq test, submit it. This is going to create an API key. You just copy it. You just put it here. And that's it. So now you should be able to just go to here and just run it. And actually, maybe I have to restart the environment so that it gets the new Groq API key. And also, by the way, don't try to steal that API key because it's just for free. I'm going to remove it as well. And now you just do Python FastRTC. Yeah. And now this sets up everything. And this is just using Groq for all the inference. So then it's going to be, so you're going to be able to run this thing even if you have a potato machine, because all the heavy lifting is happening at the Groq servers. Okay, and that was all for today's video. I hope you liked this video and you just comment me, I don't know if you found value or what are the next thing that you want me to create. I saw all the comments in the video before and I really like them. So yeah, thank you for the support that I'm getting. And yeah, also subscribe to my YouTube channel if you want to be updated in all these cool things that are happening right now in the field of AI. Bye-bye.